Hello, everybody. The title of mine, Protocoling Prototypes or Prototyping Protocols, as the name tells, is quite of a schizophrenic in certain terms, but it also has some looping duality that I'm interested. So the projects that we are constructing and designing are often in a dialogue between one and the other, enabling us to redefine the production chain of architecture from design to fabrication. So this is a mess, and that's our office. That means we have a lot of prototypes in our hands, constantly producing them, but the protocols maybe a little bit less. But I would need quickly to jump into the context where we're sitting in order to understand why we're doing what we're doing. So after nearly 90 years of absence, timber architecture absence in Estonia, the current move towards automated and sustainable building industry raises a possibility for renewable materials to position themselves back into a large-scale building economy. So the socialist ideas and norms of the building efficiency. Yeah. Is it working? Yeah. So the panelization, modulation, and element-based designs, as what we have discussed today a lot. The innovation, the material innovation, was barely in concrete, or in last years more in steel and glass. But the timber has risen, meaning that it's reaching higher levels, once again becoming part of the mass production and re-entering the materials library of architecture practitioners. But nonetheless, the timber construction has the same syntax, tectonics, as the precast concrete panels that we just saw before. And it's also visually quite similar. So for an architect being overwhelmed with the abundance of possible directions and applications, what contemporary digital tools are offering, the field of construction still remains brutally simple, driven by laws and ignorance towards collaborative work. But of course, it's not not like that. So there's also a group of practitioners in the field of renewable materials trying to construct differently, where the new panel, the new module, the element that is repeating has its design implications from the smaller element towards the aggregation of multiple elements. So that's what we are been trying to do in our office part, to combine building industry and standardized housing with research into modulation, aggregation of qualities, and of course, above all of that, spatial qualities. So with this method, modulation makes it possible to move towards more flexible and adaptable architecture. So redefining, and the way how we're doing it is to redefine the production chain of architecture from design to fabrication based on the computational understanding. So that has helped us to move from a non-looping method that you see here, what we've been trained in school. You're an architect, you get a brief, you pass it over to an engineer, to the manufacturer, and then it's getting constructed. And what we've been looking at is a way of creating a looping method. So it's a particular collaborative workflow between architects, engineers, and fabricators. Modulated prototyping provokes apparent design implications in tectonics and space organization. So the dynamic relationship between the digital, the material, and all the parts that also been discussed before, and of course the design protocols, helps us the prototypes become the key elements in design and fabrication process. So the central part, the common platform where the engineers or the practitioners are meeting, that is based on a discrete syntax, proposes a methodology that allows all component participants work in a non-narrative manner. But one could also say that it smells like design by committee. So you're aiming for a horse, but you get a camel. I want to prove otherwise by saying that before entering the common platform, an architect does a lot of things, and maybe even more things than beforehand. And also now the practitioners are in a more constant flux, meaning that it allows us to, information flux, that means it allows us to work with the live geometry, but also with the live material. And these are the two things that this allows us, meaning that the geometry is alive until the very end of the execution, and living material, that means food, for example, wood is constantly being calibrated, remeasured, and informed us. So, for example, in the live where we were designing a 45-meter high design pavilion, pylon, electricity pylon. We kept the geometry tweakable, so the manufacturers, so it's constantly calculating the amount of wood it uses, or the engineers applying all the forces there. It's calculating thousands and thousands of simulations of it, but above all, as a designer, there was always the possibility to find the perfect one for the need, and it is under construction at this very moment. And the other one, this alive material, as said, this workflow also helps to work with it. So in constructing of this one in 2015, the properties of the wood were changing because of the moist, because of different treatments it got. So it saved us from re-milling the files of 350 pieces. Just one night before the fabrication, we got the information that wood is 2 millimeters thinner than it should have been, and because of that, none of the joints or joinery would have worked. So taking that into account, we could regenerate quickly the outcome. So if there's a question, is that bringing us a camel or a horse? I think it brings us the unicorn that is fitter, faster, and more pure to its original design. It's all about the detail, as Jill also said. So this level of detailing allowing us to reach better geometry, more specific, and as well working with fluctuating materials. So quick examples on those unicorns. So for the last 3 years, we have been working and looking more into aggregational structures, meaning that there's more repetition in the element, and the space that becomes the space-defining skeletons. So for example, this one is in the main square, the Freedom Square of Estonia, that was able to define the stages, the moving locations where you're sitting areas. But it's all focusing on the structural space filling elements that are negotiating between the modularity and the smart joinery. And the joinery and the detail is something that that has become the design value that then gets into the overall form. We also used a 5-piece method, also again minimum amount of elements to create a maximum area of seating and table one. And the biggest one so far is this 18-meter one that we're using, again, 2 modules. That is a structure that has no vertical pillars. And all of this is then to fill the shopping mall atrium. So in any case, the joinery has become a detail that defines or gives information about the overall shape. So we also, of course, have been looking into more somatic structures, as we call them. So things that are a side structure also becoming a space-defining membranes qualities in them. And that brings us to the bigger scale, where somatic structures have more closed modular elements that carry aside the structure qualities, also space-defining qualities. And these are the prototypes where we used first time in Estonia the 5-axis CNC for creating the CLT panels. Or we work close to the fabricators as well, who are saying, like, by producing those buildings, we have a lot of CLT leftovers, because all the windows and doors cutted out of those big CLT planes could be maybe reused in constructing in our way, meaning smaller pieces, more aggregated, and in that terms also bring back the human scale. And the last project, the apartment building, we're constantly evaluating the relationship between the design protocols and the prototype outputs, then looking at the one module, the one that this one we haven't constructed yet, is constantly helps us also to define the space. And the spatial flexibility that those modules are giving us is also helping to keep the readability of the module. Maybe not as pure as in Chill's cases, but it is organizing, and I guess organizing is better visible here. It's organizing the compact system of the modules, functioning aside structural elements as well in surfaces. So the purity of the material is actually here. We don't need to cover the interiors with any other plate materials. So the methodology of the workflow analysis has enabled us a new knowledge about how we design from part to whole, from detail to overall. So the applied protocols, parameters, and physical materials prototypes are providing specific tectonic and allowing us to emerge and extract new designs from it. Thank you.
Thank you.